Math lesson number 28, radicals. Let's start with this word problem. Selena has a rectangle with a length of square root of 27 meters and a width of square root of 3 meters. What is the area of the rectangle? Now, to compute for the area, this is the formula. Area is equal to length times width. So square root of 27, that's the length, times square root of 3, that's the width. So as you can see, square root of 27 times square root of 3 is equal to square root of 27 times 3, which is equal to square root of 81, because 27 times 3 is 81. And square root of 81 is equal to 9. Therefore, the area of the rectangle is 9 square meters. Now, in this example, we need to know more about radicals and operations involving them. So if we have a square array of 81 dots and we wish to determine the number of dots per side, then we use square root of 81, which is equal to square root of 9 squared, which is equal to 9. So there are 9 dots on each side of the square array of dots. So that's how radicals work. Now the symbol read as the square root of is called a radical sign. The number inside the radical sign is called the radicand, and the whole expression is called a radical or a radical expression. The radical expression square root of 81 is the same as square root of 81, in which 2 is called index. So no need to write for 2. It is already understood that there is 2 there. Now in the radical expression, cube root of 8, 3 is the index, 8 is the radicand because 8 is inside the radical sign, and cube root of 8 is read as cube root of 8. Now let's have other examples. This one is read as 4th root of 81. This one, 5th root of 32. This one, 4 square root of 36. This one, 5 26th root of 1. Now let's have simplifying radicals. To simplify square root of 81, we need to determine a number n such that n times n is equal to 81. So we know that 9 times 9 is equal to 81, and negative 9 times negative 9 is also 81. Hence, 81 has 2 square roots, which are 9 and negative 9. Now, the principal square root of 81 is the positive square root, which is 9. To simplify cube root of 8, we need to determine a number n such that n times n times n is equal to 8. We know that 2 times 2 times 2 is equal to 8, but negative 2 times negative 2 times negative 2 is equal to negative 8. Hence, 8 has 1 cube root, which is 2, and not negative 2. So cube root of 8 is equal to 2, cube root of negative 8 is equal to negative 2. Now let's have the relation between radicals and rational exponents. So let's have the rational exponent 1/2. 81 raised to 1/2 is equal to 9 squared raised to 1/2, which is 9 raised to 2 9 raised to 2 times 1/2. 2 times 1/2 is 1. So 9 raised to 1 is equal to 9. Square root of 81 is also equal to 9 because 9 times 9 is 81. Therefore, 81 raised to 1/2 is equal to square root of 81. Next, 8 raised to 1/3 is equal to 2 raised to 3 raised to 1/3. which is equal to 2 raised to 3 times 1/3. Again, 3 times 1/3 is equal to 1. So 2 raised to 1 is equal to 2. So 8 raised to 1/3 is equal to 2. Cube root of 8 is equal to 2. Because 2 times 2 times 2 is 8. Therefore, 8 raised to 1/3 is equal to cube root of 8. Notice that the denominator of the rational exponent is the index of the radical. So in this example, 8 raised to 1/2, the denominator of the exponent is 2. The index here is 2. Here, the denominator is 3. The index is 3. So take note of the relation between radicals and rational exponents. So in general, for any real number a and any integer n is greater than or equal to 2, a raised to 1 over n is equal to nth root of a. Examples, 16 raised to 1/4 is equal to 4th root of 16. So as you can see, the denominator is 4, the index is 4. 32 raised to 1/5 is equal to the 5th root of 32. X raised to 1 over 50 is equal to the 50th root of x. Next, for any real number a and any relatively prime integer m and n, meaning to say m and n have no common factors other than 1. That's the meaning of relatively prime, such that n is greater than or equal to 2. A raised to m over n is equal to the nth root of a raised to m. So as you can see, the denominator is n, the index is n. The numerator is m, the exponent of the radicand is m. So again, denominator is the index, the numerator is the exponent of the radicand. Provided that the nth root of a exists. So here, m is the exponent of the radicand and n is the index. Okay, the whole expression is read as nth root of a raised to m. So let's have example. 16 raised to 3/4 is equal to 4th root of 16 cubed. So 4 denominator, 4 is the index, 3 is the numerator, 3 is the exponent of the radicand. Number 2, 32 raised to 7 over 5 is equal to the 5th root of 32 raised to 7. Take note, again, the denominator is 5, the index is 5. The numerator is 7, the exponent of the radicand is 7. X raised to 26 over 50 is equal to the 50th root of x raised to 26. Same thing, same reason. The denominator is 50, the index is 50. The numerator is 26. The exponent of the radicand is 26. Let's have more examples on simplifying radicals. So let's have 4th root of 16 cubed. So 4th root of 16 cubed is equal to quantity 4th root of 16 and then quantity cubed. So 4th root of 16 is 2 because 2 times 2 times 2 times 2 is 16. And then 2 cubed is 8. Therefore, 4th root of 16 cubed is 8. Next, we have 2 times the 5th root of 32 raised to 7. So first, we separate 2 and then 5th root of 32 raised to 7. 5th root of 32 is 2. Because 2 times 2 times 2 times 2 times 2 is 32. Now, 2 raised to 7 is equal to 128. And then 128 times 2 is 256. Another method, 2 times 2 raised to 7 is 2 raised to 8. So we will add the exponents 1 and 7. So that's 2 raised to 8. And 2 raised to 8 is 256. Number 3, 50th root of x raised to 26. So as you can see, this radical expression is turned into exponents. So x raised to 26 over 50. So that will be x raised to 13 over 25. So the lowest term of 26 over 50 is 13 over 25. Now this will be turned back to radical expression. So denominator is 25, index is 25, numerator is 13, the exponent of the radicand is 13. So that's the simplified form of number 3. Number 4, cube root of y raised to 12. Again, change this to exponential expression, just like this one. So y raised to 12 over 3. So again, 3 is the denominator, 12 numerator, and the exponent. So 12 over 3 is just equal to 4. Therefore, cube root of y raised to 12 is just equal to y raised to 4. Let's have number 5, square root of 100. We know that 10 times 10 is 100, and negative 10 times negative 10 is also 100. Therefore, square root of 100 has two roots, which are positive 10 and negative 10. But usually, the principal root or the positive root is considered. So square root of 10 is equal to, square root of 100 is equal to 10. Number 6 is square root of 24. Take note, 100 is a perfect square, so it's easy for us to get the square root of a perfect square number. Now how about this one, 24? 24 is not a perfect square number, meaning to say, there is no whole number in which when that whole number is multiplied by itself, you will get 24. How are we going to simplify square root of 24? So let's have this one. Square root of 24 is equal to square root of 4 times square root of 6, because 4 times 6 is 24. Why 4? Because 4 is a perfect square number which is a factor of 24. So again, you need to find a perfect square number which is a factor of the radicand, 24. So in this case, 4 is a perfect square and 4 is a factor of 24. So we will use this, 4. Now we will extract square root of 4 from square root of 24. So the remaining now is square root of 6. Again, 4 times 6 is 24. Now square root of 4, considering the principal root, we have 2. And then plug in square root of 6, square root of 6. So square root of 24 is 2 square root of 6. Another example, 2 square root of 45. That is 2 square root of 9 times square root of 5. Why square root of 9? Because 9 is a perfect square number which is also a factor of 45. So 2 times square root of 9, which is 3. So 2 times 3, that's it, which is 6. And then plug in square root of 5. So 2 square root of 45 is 6 square root of 5. Now let's have variable radicand. Square root of x raised to 4. X raised to 4 is a perfect square expression. So square root of 4, square root of x raised to 4 is x squared, considering the principal root. Next, we have square root of x raised to 5. So this one is not a perfect square. Again, we need to find a perfect square factor of x raised to 5. And that is x raised to 4. So that's the highest perfect square factor of the radicand. So square root of x raised to 4 is x squared, because x squared times x squared is x raised to 4. Then plug in square root of x. So square root of x raised to 5 is x squared square root of x. Now what if the index is not 2? So let's have cube root of 24. So we need to find a perfect cube factor of the radicand 24. So we know that 24 is 8 times 3, and 8 is a perfect cube. Why perfect cube? Because 8 is equal to 2 times 2 times 2. So 8 is a perfect cube. Now, cube root of 8 is equal to 2. Plug in cube root of 3. So cube root of 24 is 2 cube root of 3.